Greetings to lecturers and my fellow classmates. Today we are going to talk about the topic gear train. First and foremost, let me introduce ourselves. I'm Vigendran and these are my classmates Surya, Ifa, Fakrol and Hazik. Gear trains refers to a series of gears that operate together to transfer rotational motion. Simple and compound gear trains are normal. Epicyclic gear trains provide angular movement between gear axes. When reducing speed or mechanical advantage, gear trains are necessary. If the distance between the shaft is neither too short nor too long for a single anonymous gear, we have a gear train. There are four types of gear trains. They are simple gear train, compound gear train, riveted gear train, planetary or epicyclic gear train. The next slide will be explained by my teammate Ifa.
Firstly, this is the simplest gear train for transmitting motion. This type of gear train has locked gear axes and gear placed on their own shaft. Picture below shows a simple gear train with one gear per shaft. A is driver, B is driven. When the distance between the two shafts is minimal, gear 1 and gear 2 mesh to transmit motion. Gear 1 is the driver since it drives gear 2, while gear 2 is the driven or follower. The drive gear rotate anti-clockwise. Next is compound gear train. Compound gear on intermediate shaft had intermediate gear span the gap between the both driver and the driven or follower. Each intermediate shaft has two fixed gears that rotate at the same speed. One gear meshes with the driver and the other with the driven or follower. As indicated, the driving gear is on shaft A, whereas gear 2 and 3 are on shaft B. 4 and 5 are compound gear on shaft C, and 6 is the driving gear on shaft D.
And thirdly, in reverse gear train, both the first and last gear axes are coaxial. To all appearance, gear 1 is in fact pushing gear 2 in the opposite way. In this case, gear 3 rotates in the same direction as gear 2 does because gear 2 and 3 are also fixed to the same shaft. When in third gear, the drive shaft is pushed forward into fourth gear in the opposite direction of first gear. Since the first and last gear is in the reverse gear train, move in a manner analogous to one another. This demonstrates that the gear can be interchanged. And lastly, planetary or epicyclic gear trains have shafts with movable axes relative to a fixed axis. Figure depicts a simple epicyclic gear train with a common axis at O1 around which A and C can revolve. The gear B meshes with the gear A and revolves on O2's arm. If the arm is immobile, gear A can drive gear B or vice versa. If it fits and rotated about gear A's axis, gear B must spin on and around gear A. Epicyclic motion is when gears travel over and around each other. There can be either simple or compound epicyclic gear trains.
For the next part is gear selection. Let's choose rack and pinion gear. Rack and pinion gear are the type of gear that are used to convert rotation into linear motion. The rack and pinion gear system are divided into two gears, where the rack is the flat or straight gear, while the pinion is the normal round gear. There are few types of gear for rack and pinion, one of which is a straight tooth gear that has a tooth axis parallel to the axis of rotation. Another type is helical gear, where the gear teeth have a certain angle. Rack and pinion gear have many practical use, as is it an efficient way to convert rotary to linear motion. Rack and pinion are commonly used in automotive industry, for example, the steering system of the car. Next, for the design of rack and pinion. The number of teeth of the pinion gear is 30, while the rack gear is 48. The gear ratio is equal to T driven divided by T driver. T T-driven is the right gear, while T-driver is the pinion gear. The gear ratio is 1.6.
Hi, nama saya Surya Vishnu. Today I'm going to present discussion and conclusion. Discussion. There are some difficulty and challenges while designing a new gear system, and it needs to expertise and experience in some engineering techniques. The majority of the pitfall and problems associated with a new design is related to an evolution of several areas such as lubrication, cooling requirement, complete static and dynamic load analysis, material, and the most recent manufacturing technology. Some of the typical issues encountered through the gear design process are highlighted along with tips of avoiding these circumstances. The term gear ratio refers to the output to input ratio, which is represented by the equation below, where output is commonly stated as the number of teeth on the driven gear and the input is often expressed as the number of teeth on the driving gear ratio. Conclusion. From this discussion, we are able to understand the gear train concept in both diameter slip definition and open definition, which allow the output shift to spin at the same speed while keeping the total of their speed proportionate to the input shift. The design of these mechanical elements include an optimization process, which is designers consider certain objectives such as strength, weight of vehicle, corrosion, and some other aspects which depending on the requirements. It is required to optimize such as mechanical elements to make the whole assemble efficient and cost effective. We achieve our objective through this project. Thank you.